Hi there! In this screencast, we're going to look at the debugging experience in CLion. Now, CLion comes with support for GDB, and in most operating systems, GDB is actually bundled with CLion. The only exception is Ciguin, where you have to install it from the local package manager. You can see GDB here as part of the overall verification process of the toolchain. So I've got GDB set up, and now I can actually go and investigate how my program is behaving. So the simplest thing that I could do is set a breakpoint at a particular location. So for example, I could set a breakpoint here, and now we need to talk about the way that CLion actually figures out what to debug. So in your CMake list file, you essentially have at least one target. So here I have a target called hello CLion, and what CLion actually does is it figures out where the targets are and what targets can be debugged. So here from the list of configurations, we have to explicitly select hello CLion before debugging. Now let's get back into our file and press the debug button. So this causes compilation, and then execution pauses at this particular location. So here what we can see is the states of the variables that have been initialized so far. So that would be h1 and BMI. I can expand h1 to see the properties of both the human class, or if I expand a little more, I can see the inherited property from the animal class as well. But I cannot just look at the properties, I can also modify the properties. You can see that we have a useful highlighting here for showing the current values of a variable. So I can see that the current value of BMI is equal to 24, but what I can do is I can right click it here and I can set a different value. So for example, I can set a value of 30, for instance, and after I press return, notice that the value gets changed here. It's also a different color, indicating the fact that it's been modified, and it's got a different value in here as well. In addition, I could always take the BMI value and add it to the watch list, or I could perform a particular calculation. So instead of calculating the BMI value, what I could do is I could evaluate an arbitrary expression. So for example, I could take the BMI value and divide it by 2. I would press the evaluate button to get the actual value, and then if I wanted to watch that, for example, I could right click it and add it to the list of watches in my debugging pane. So far, we've got a list of values and we've got a watch. So let's actually use the debugging tools to continue execution. So to step over some of the constructors that are being invoked here, I can press a shortcut to sort of navigate to a particular location. Notice that we're getting further hints and further information in the variables list as we go along. I'll press this a couple of times more, but now let's suppose that I actually want to get into the getBMI function and figure out what's going on. In this case, I will step into it, but to begin with, I end up in the STL vector class. So let's step out of this and let's actually step into the getBMI function. Now here inside the function, we're calling another function called square. So once again, I can press the step into key, and notice that for the argument x, I get to see the actual value. And of course, if I wanted to, I could also modify this value if that was required. So as we continue execution, we end up at the beginning of the for loop once again, and this is how you can go over the entire application and look at what's being executed line by line. So in addition to the features that we've already seen, I also want to highlight the fact that we have a set of threads here which you can inspect, and also the listing here actually shows you the stack. And let's also look at some of the ways in which exceptions are being handled. So if I stop execution for a moment, and we can look at how exceptions are handled, and also how you can customize the breakpoints to work better for you. So let's actually begin with the breakpoints, because when you make a breakpoint, that's kind of an unconditional stop in your application, but you can right click it and you can specify a condition. So for example, maybe I want this breakpoint to trigger only if BMI is less than 50. Or if I want more customization, I can press the appropriate shortcut here, and this will open a full breakpoint customization window. So in addition to the options of whether I want to suspend on this breakpoint and whether I want it to be conditional, I can also log a particular message to the console, or I can actually log an evaluated expression, just as we saw when we evaluated half of the BMI value. I can do the same thing here. I can also remove the breakpoint once it's been hit, and you can also set up more complicated relationships between several breakpoints. So these are the breakpoints related to a particular line, but we also have something called exception breakpoints. So let me demonstrate how this works. Now, at the moment, the way that things are set up is I've got a try catch here, and I'm trying to address an element of people that does not exist. So what would happen if we tried to debug this application? Well, nothing would happen. We don't have a single breakpoint, so it just executes it prints some presumably incorrect result or tries to address memory which is not available, but nothing really happens. What if we want to actually catch the exception and set up a breakpoint at the location where the exception is thrown? Well, in this case, what we can do is we can press this little button which opens once again the menu for exception breakpoints. I will enable those breakpoints, and I will first of all select the when thrown option. This will actually hit a breakpoint when the exception is thrown. So now if I press done and we run this once again, we should hit a breakpoint right inside STL vector, and that's exactly what happens. So inside STL vector, somebody does a range check, and this range check throws an out of range exception. And this is you can see the stack here on the left, and you can see the end variable here on the right. So you get some internal information from STL as well. But what if we want to actually have the breakpoint trigger when the exception is caught? Well, this is also possible. If we go into main.cpp once again, and we go into the settings, so we'll go into here, and instead of when thrown, we'll choose when caught. Now a different situation will arise. So we'll press the debugging button once again, or you could have used the shortcut, but now we end up in our code. So we end up seeing our actual structures and everything around us. And by the way, notice that people, for example, is a vector, and we can actually expand this vector and expand the elements. So this is enabled by the power of STL renderers, which are available in CLion and actually help you visualize common STL constructs such as vectors or maps or that sort of thing. So as you can see, all the debugging controls are available either as buttons on the debug pane or alternatively as keyboard shortcuts that you can press. So we have a listing for the frames, for the variables. We also have the GDB console itself, just in case you need to look at it. And we also have the proper console, so to speak, which collects the output from the application that's being executed. And this is the gist of the CLion debugging experience. So to find out more about CLion, go to jetbrains.com/CLion, and thanks for watching.